Sir Roger Penrose is a true giant of math and physics. Anyone who works in relativity, cosmology and black holes will surely know his name. Dozens of important discoveries and principles bear the name Penrose. Some of the more beautiful and beguiling areas of mathematics are also his doing, such as Penrose tiling. His breadth of work and interesting life would be impossible to fit in a book, yet alone this brief podcast. Were you a prodigy? Would someone have seen you in school and thought, this boy's destined for greatness?
No. Well, you see, I was often compared with my older brother when I was very young. Well, I should explain, I was in England up to the age of 7. I had my 8th birthday in Canada. This was when the Second World War broke out, and my parents decided to stay in Canada. They went off. War was looming rather at that stage. I have some memories of when I was in England. I sometimes tell people this story. I don't know what you make of that. You see, I never like to eat spinach. This is something has changed when I got older. I love spinach now. But in those days, I just couldn't stand it. And you see, we had a well-off family, and there was a nurse or somebody, I think, I don't know, the cook. We had various people to look after us because my father was very well off. The nurse or whoever it was had decided that I ought to eat my spinach, which was a sort of circular spot on the plate. And so I said, no, I don't want my spinach. So she said, well, all right, eat half of it. I said, how about if I eat half of it? So she said, okay, eat half of it. All right. So when she was out of the room, I carefully made this circular patch into a semicircular patch of the same volume. And when I came back, she said, that's very good, thank you. And so she was quite completely satisfied. So if that gives you any hints, I don't know.
You had 2 brothers, and they were both quite capable boys, were they?
Well, you see, they were more prodigious, or whatever the right word is, than I was, because Oliver, my older brother, was certainly a prodigy. When we were in Canada, he went to a thing called the advancement class, and that set him ahead 2 years. And so he went immediately into high school when I guess he was 10. He was 2 years younger than the next youngest. And he was second in the class. He was certainly a prodigy, and he read all sorts of things. It's very useful to me because he taught me quite a bit of physics when I was young, just sort of basic things. But I think I learned a lot from him. I learned a lot from my father, certainly. He was a scientist, but not a physicist. He was on the biological side, but he knew quite a bit of maths.
Yeah.
I learned mathematics from him, but the physics, I think I got a lot from Oliver, my older brother. My younger brother was a prodigy in a completely different way. He was very good at games, and he later on became the British chess champion, a record 10 times. And he was really good already at the game of chess. He could beat me at pretty well all games. Not quite, but pretty well. I remember this game, scissors, paper, and stone, you know, this thing. And he used to wallop me at that game. I couldn't quite understand how he could beat me that game, and it seemed to me it was a pure game of chance. And I wondered whether he was reading my mind or something. So I went and I got hold of a table of log tables and opened the thing right in the middle and had a code for what the numbers were, which was stone, which was paper, and all that.
Yeah. And
I had made a long strip of paper, and I just followed that, and I broke even. So this was a lesson to me, you know, that if I was doing randomly, as I was trying to do, but he was doing psychology on me, obviously, and he was sort of predicting what I was thinking, which is a little bit unnerving, but...
Professor, when you reflect on your upbringing and the fact you had this scientist father, you had a older brother who was exceptional, you had a younger brother who was exceptional, do you see that as shaping you in any way? It made you into the professional you later became?
Probably, in some ways. As I said, I think I learnt things from my older brother, Oliver. I learnt not to play chess from my younger brother, which was useful. I could have wasted a lot of time on chess. And not to spend too much time on games. I think that was probably educational on.
Was there a competitiveness, though? Did you feel like, were you fueled to keep up with them?
There was a competitiveness, I think, yes. That's true. Certainly there was with my younger brother, I felt. I think when it came to physical games, I was a little bit better. Because, of course, he was 2 years younger than I was. Like badminton, which he used to play too, and things like that. Although he's pretty good too, things like that. But he wasn't a mathematician. People used to think, you know, chess and maths go together. Oliver was a good chess player, but he wasn't as good as Jonathan. He became Cambridge University champion. He was that good.
Right.
But I didn't attempt to play chess. I just was out of completely nothing I would try to do.
So, Professor, if I went back in a time machine and met the three brothers Penrose, would I have guessed you were the least likely to sort of, become this knight of the realm, fellow of the Royal Society, acclaimed physicist and mathematician? Or would I have picked it?
It depends. There was one person I remember who did. I think he regarded me as the dark sheep of the family. This was Oliver Strachey, who actually was a high up, and I didn't know anything about this, in what became the GCHQ. He ran it at one time. Nobody knew anything about that.
Yeah.
It was all dead secret. But I think he spotted something. I don't know. I don't know what it was. But on the whole, I think I was known for my brothers and not myself. But I didn't do terribly well in school. I did get moved down a class when I was in high grade 3.
What, you got demoted?
I got demoted at school. Yes, you see, the teacher whom I didn't get on with at all, and she had shared what was called high grade 2 and low grade 3. And I was in low grade 3. And she considered I was too stupid for low grade 3, mainly because I couldn't keep up with her and the class with mental arithmetic. She would give, you add 3, multiply by 7, subtract 15, whatever it was, you see, and I'd get completely lost before they got going.
Yeah.
That sort of thing, I was completely, and I was very slow. I was very, very slow when I was young. And she moved me down and then decided I was too good for high grade 2 and not good enough.
Right.
She didn't know what to do with me.
You were a bit stuck in the middle.
I was stuck in the crack between those two, the narrow crack. But eventually she got rid of me by moving up to high grade 3, just to get rid of me, I think. And I got on better with the teacher. And I did have a teacher, I think later on, not grade 3 teacher, I forget, it was grade 4, grade 5, I don't know, whatever it was. Yes, there was something about skipping a grade, which I think I did.
Right.
I don't remember now. But the teacher who I thought was very insightful, Mr. Stinnett, and he had looked at my exam papers and realized that I did pretty well at the beginning and then sort of tapered off when I couldn't do anything. It's just that I was too slow.
Right.
And that allowed me it's supposed to be one period where you're supposed to do the test in, and then he allowed me to take the game, what was the play period after that, and still keep going, and sometimes the period after that as well, working away at the test. And then I would do very well. I'd get in the high 90s. I think a lot of it was not being able to remember my tables and things like that. I had to work them out of my fingers or whatever it was, you see. I knew what I was doing, but I just had to figure it out more from first principles rather than remembering it.
Professor, if I got into that same time machine and went back and spoke to the boy Roger Penrose and said, what do you want to be when you grow up? What's the job you're aspiring to? What do you think he would have told me?
At that time, when I was in Canada as a school kid, it would have been a doctor.
Right.
Medical doctor. They had some vocational guidance. No, I can't get the right word. It was something where you had to score in 2 different ways, and it met in the middle, and it was always on the doctor. Right. I think I did it twice. Yes, I did IQ tests too. Right. The first time I did pretty well. The second time my IQ had come down considerably.
Right.
I think it was because you had to divide by something to get your IQ, and as I got older.
Did the idea of being a doctor appeal to you for the job that it was, or just because it's what the test told you should be?
Partly what the test told me. Partly because secretly I was not going to be a GP, a general practitioner or something, which my mother thought. You see, she thought I would have a good bedside manner or something. I think my bedside manner would have been okay, but I wouldn't have remembered the names of any of the drugs, and I'd have got them confused. It would have been completely hopeless.
Right.
But what I secretly was going to do was to be a brain surgeon.
Right.
And I thought I would open them up and figure out how the blasted thing worked. You see, this was, which in a sense came back in a certain way later on in life.
Yeah.
I never followed the medical degree because, as later on when I was back in England and we had to decide what we would do in the final 2 years, each of us individually had to go and see the headmaster. And he said, what do you want to do in your final 2 years? And I said, I'd like to do biology, chemistry, and mathematics. I think it was chemistry and not physics, because the chemistry teacher was more exciting than the physics teacher, who was a bit old and it came too much from him. The headmaster said, well, I'm afraid you can't do that. If you want to do maths, you can't do biology. If you want to do biology, you can't do maths, I'm afraid. Make your choice. So I said mathematics, physics, and chemistry. And this was a big change in my life.
Yeah.
I said mathematics because I'd learned to love maths, which was something I'd had a feel for, even though I was extremely slow even before that. And I used to make polyhedra with my father and all sorts of things. And I made a slide rule for working out the date and things like this.
Professor, if you were a little bit slow at mathematics, like it was something that would take you a long time, what was it that appealed to you about mathematics? What was it that, that day sitting with the principal and when the principal saying, okay, it's biology or mathematics, you chose mathematics. What was it that appealed?
I just loved it. But it was partly, I had, remember, 3 teachers. And the teacher that I had in the end is the one I got on best with. And there was one point, she said something at the end. It was about differentiation and smoothness of curves or something. And he said something, which I said, look, that's not, what you said isn't quite right. He said, well, what? And I said, no. Yes, I said, if you take y equals x to 5/3 or something, then it has an inflection. But its second derivative doesn't vanish at the origin. And he didn't believe me, and he made me plot it out. So I plotted it out nicely, and you could see it actually just did that beautifully. Well, that way it looked.
And what was it about that interaction that was special to you? Just you enjoyed pointing, you enjoyed calling out the teacher?
I think I did, yes. And you could see him pulling books out of the shelves. And I think people would nudge me and say, look, he's...
You've got him. Yeah.
Yes, and he finally found the same curve, you see, and he agreed with me. He says, well, it goes to infinity at the origin. That's well, I knew that.
Professor, can I just go back in time a little bit more to your school days? Because obviously later in life, one of the things you've become famously associated with is black holes and some of the more exotic things in space.
Yeah.
As a boy growing up, I was obsessed with the idea of black holes. They were amazing to me. But you wouldn't have had black holes when you were a boy as an inspiration, would you? The name black hole hadn't even been coined at that point, I imagine.
That's true. Well, apparently it was Wheeler. I'm not sure. I think it was fairly in common practice by the time I got interested, but I should go back a little in the history.
Yeah.
Because, well, what stimulated me, you see, there were other things earlier on, going back, particularly, well, people go back to Chandrasekhar, who discovered that white dwarfs, if they were more massive than a certain mass, there was nothing to stop them. And then there were neutron stars. And again, you had this problem that there was nothing to stop them if they were too massive.
Were you captured by the idea of these things as a boy? Like, would you read books about space and look at the stars and be excited, or was that not on your radar yet?
It was. Again, you see, my father was a big influence on me. And I remember when he decided, I told him that we were going to learn calculus the next day, and he instantly took me away and taught me calculus. He wanted to be the one to teach me and say how wonderful.
Really? Because he wanted to give you a head start at school, or just because he wanted to be the one to impart the knowledge on you?
He wanted to be the part of the knowledge. It wasn't being a head start. No, it wasn't that.
Right.
He just thought there was something really beautiful about it, and he wanted to convey this to me. And he did, and it was true.
Yeah.
And I picked up on it enough to realize how beautiful that was. But Chandrasekhar, the work that he'd done and all that was not known to me at that time. But you see, my father had a telescope, which incidentally I had inherited, but I can't never get it to work because it's, you have much better telescopes now.
Do you still have it now?
Yes. It's an old brass one.
Yeah.
I think I remember when he was I can't remember whether he was married or courting his mother, and they're camping on a mountain because there was a total eclipse of the sun. And he had this telescope, and he'd seen it had a special lens for dark lens, so you could look at the sun.
Good.
Yeah. And he and my mother saw the eclipse with this telescope.
Yeah.
And just when they'd finished looking at it, all the people came rushing up the mountain, and they just missed it. But the same telescope, much later, I remember him looking at Saturn, and he showed me Saturn.
Yeah.
And and there was something very, I would say, influential about seeing Saturn.
Yeah.
It was I'd seen pictures of the rings and all that. And when you saw it in the telescope, and there it was, the little speck of light in the sky, and suddenly you see it, and it's really got the ring. It's there. And you can see it there yourself. And this made a big impression on me.
I think anyone who's looked at Saturn through a telescope never forgets the first time they see Saturn.
That's right. And it certainly had that effect on me.
When did you make the transition from thinking, oh, well, I guess I'll be a doctor, to something else?
That was when I went the walk up to see the headmaster.
Right.
Because up to that point, I was still going to be a doctor.
Right.
I just had fallen in love with mathematics.
So being forced to ditch biology in order to pursue mathematics is when the doctor thing went out the window.
Down the tubes, yes, I'm afraid.
Yeah.
And I went home, and both my parents were furious.
Really?
I remember they were annoyed with me because one of my friends at that time, who wanted to become a scientist, and he wanted to do nuclear physics. He never did it, as it turned out, but he wanted to do nuclear physics. And at that time, it was the worst crime in the world to do nuclear physics, because my parents were both pacifists, and the idea of nuclear bombs was the most dreadful thing you could think of.
Yeah.
So that was a bad thing. So if you did physics.
When you were telling your parents, look, I've decided to pursue mathematics and biology's gone out the window, as has being a doctor, what were you telling them? What did you say to your parents? Look, I think I want to be a mathematician. I want to be a physicist. What was your rationale to them?
I didn't want to lose the maths. I didn't exactly want to be a mathematician at that time. And you see, there was a second phase of the same thing, which happened later, because I did this mathematics, physics, and chemistry, and I did all those subjects for my, what do we call it? There were different things in those days.
Yeah.
So I didn't forget what they were called. High school certificate.
Yeah.
That's what it was. And I did that. And I did mathematics, physics, and chemistry. I think my best paper was in mathematics, as far as I remember. And I think I felt I would want to do maths. I wanted to do mathematics because I just grown to love the subject more and more as the time went on.
Yeah.
Then I proposed I would go and do mathematics as a degree, for a degree.
Thinking what? I'll be a math professor or?
Mathematics, yes. Yeah. I didn't know quite who would be a professor or what I would do with it, but yeah. I wanted to do maths. I was proposing to do it at a university college, which was my father's. He was a professor of human genetics at University College. And there was an advantage there because you could go without paying. Whether they paid the whole fees or just half them, I can't remember.
Right.
But because he was a professor there, there was some advantage. So I wanted to go to UC to do mathematics. And he was not happy about this at all. He said, well, if you're going to do maths, if you can do other things, you understand about physics and things like that, and biology. And he had the view that mathematicians were people who just did mathematics were pretty odd people. They just sort of focused in this direction. And he considered that he didn't think that was a very good idea for me. I think it was in a way a compliment because he thought I could do other things. And he thought these sort of odd people who were sort of separate from the world would do mathematics. So he did do something, I must say, was to his credit. He got one of his teachers. He was called Kesselman. And he was as I learned later, an extremely good teacher he was. And he made up a test of whether it was 6 or 12. I can't even remember whether it was 6 or 12 very special problems. They were not the things you would have come across, but not beyond my sort of knowledge and capabilities at that stage, but unusual problems. There were certainly 6. I think there may well have been 12. And he said to me, look, I've got this set of problems. You may find that you can only do half of them, maybe only 2 of them. Yeah. That's fine. Do what you can. I worked away for the whole day and did the whole lot.
Right.
And when he picked them up, he was quite impressed by that.
And he would have said to your dad, this boy's got it.
He's got it, yes. Yeah. He did say that, yes.
And then your father kind of gave his blessing at that point, did he? When Kesselman told him, he's good. He
gave in. Oh, he didn't completely give in because he thought I ought to go to Cambridge. And there was a rather not very good set there because I think I'd done my first year already.
Right.
I think I was in the second year, and he thought I should go to Cambridge. And so he wanted me to do the Cambridge scholarship exam. I can't remember quite when it was, maybe only in my first year.
Okay, so then the money thing wouldn't have been an issue because you would have been on a scholarship.
That's right.
Yeah.
I should explain that while my father was well-to-do before this, he'd given almost all his money away. He gave it to charities and that sort of thing. He hated money.
Right.
And so he'd pretty well given it all away by then.
Okay.
A very curious point of view he had on various things. But I can't quite remember. I think it must have been in my second year when I did maths. I discovered a theorem, which I believe is still unknown. And I never published it. But I gave a seminar when I was in my second year as an undergraduate.
Yeah.
On this thing. And my father attended and must have heard about it, yes.
What was it, without going into the detail, what was it about? Is this Penrose's forgotten theorem?
It's Penrose's theorem, which hasn't even been seen because it was never published.
Oh, this could be an exclusive.
I never did it, yes. It was a theorem about conics.
Yeah.
It's not so hard to explain, actually, what it is. But I'd learnt about various theorems from our geometry teacher, who was a sort of an oddball. He was called T.L. Wren, and he had his own way of doing it, which was very sort of formal. He went along so the class didn't exist, more or less.
Right.
Everybody hated him except me. I loved his lectures. and I sort of picked up on various things and saw how to generalize them.
Right.
This theorem is a theorem about conics. Now, a conic is like an ellipse or a circle ellipse, a hyperbola. And the only property you need is when they have double contact. So that's when they touch at two places. So you can imagine one of your conics, ellipse like that, and then another one inside it, which touches here and touches here. And that is the condition. Now, imagine a cube. And I used to do this cube with one blob at the top, 3 in the middle, and then 3, and then 1 at the bottom. So you have this, and you should think of the way the vertices are connected with the other vertices. Now, each vertex of that cube represents one of these conics. If the two vertices are connected by a line, they have double contact. The theorem is, if you've got your cube almost finished, except for one vertex, there are 3 more lines you've got to fit in, and the last conic's got to be there, it exists. The last one exists. And that's a theorem. The point about it was you could specialize in all sorts of ways. You could make it a pair of lines, you could make it conical lines and 3 lines, and all various theorems like Pascal's theorem, Bianchon's theorem, Poncelet's theorem with triangles, Desargues' theorem, Papis's theorem. All these theorems, you specialize in different ways, and you put little symbols in the little blobs representing conics to say how they specialize, and you get all these theorems out as special cases. That's why I was quite proud of this theorem.
Why did you not publish it?
Why not publish it? You're digging deep into something in my personality, which I'm not sure. I'm not sure what it is.
Do you have lots of these unpublished things in a drawer, do you?
I have a few others, yes.
Yeah.
I did have 1 or 2 others.
Why don't you publish these things?
I kept meaning to, and other things kept getting in the way.
Yeah.
John Conway almost published it. I think he didn't, because I think he died. He was going to write a book. I don't know if you know. He was going to write a book on triangles. Do you know anything about that?
I don't.
No, his intention was writing a book on triangles. And he wanted to put my theorem in it. And I explained it all to him. Why is that a book? Why a thing on triangles? Because you get triangle theorems out of it. And he was quite taken by my theorem. And so he almost published my book, my theorem, in his book. I have no idea how far.
Let's get it out there sometime, Professor. When the pandemic's over, I'll come and visit you and give you a piece of brown paper and you can explain it to me. Did you ever sit that scholarship exam?
I did.
Yeah.
I'll tell you what happened. I did some of it. I did badly in one of them, I know, because I had a cup of coffee at the beginning. And in the middle of it, I had a real need to go to the loo. And it just distracted me completely.
Yeah.
And I messed up that paper, I know.
So a cup of coffee stopped you being a Cambridge undergraduate?
I don't know. I was relieved. I came just below.
Literally, you were relieved.
Yes, well, I was relieved a little bit at the end after the particular exam.
Was your father disappointed you didn't get into Cambridge then?
Yeah, I was glad. I didn't want to go to Cambridge because I thought, well, I'm wasting my time. I liked my course at University College. I thought that was. I did go to Cambridge afterwards. I went there to do research.
You obviously started merging your mathematics with physics very famously in many, many famous ways. Now, do you consider yourself a mathematician or a physicist?
Well, I have 2 ways of answering that question. The way I normally answer it, although I'm not sure whether it's still true because people say it's the other way. I say that if I'm with physicists, I'm a mathematician to them. If I'm with mathematicians, I'm a physicist to them.
You're always the outsider.
I'm considered that I was normally the outsider, yes. I think that's true still, to some degree, that I am a sort of outsider in that respect, yes.
When you travel and you have to fill out that form saying what your occupation is, what do you write?
Mathematical physicist, usually.
What, you write that on like your passport, like customs form and stuff?
I forget it depends what kind of space there is for what you can put in there.
Okay.
I do tend to say mathematical physicist, yes.
Obviously, at university, you're doing quite pure mathematics to start with. How do you start getting tugged towards physics?
Well, I should explain that in Britain, mathematics degrees is not entirely pure mathematics. At my stage, it had three parts to it. It was analysis, algebra and geometry, applied mathematics. And applied mathematics was what people might call physics.
Yeah.
You learn about, Lagrange's equations and Newtonian dynamics and electromagnetism. I'm not sure which of these things I learned at courses that I sat in on afterwards, because when I did my undergraduate degree, I specialized. At University College, there's a slightly strange rule. It's a 3-year course, and the first 2 years were general. Everybody did the same thing. And the final year, you specialized.
Yeah.
And I did a paper on the first 2 years, and then I did a specialist paper on the specialist papers. And the specialist subject I did was algebraic geometry and projective geometry.
Right.
So, but I'd done applied mathematics and I'd done analysis and I'd done the algebra. My best paper was on algebra, not geometry.
Right.
No, that was my specialist topic. Why wasn't it? Well, I could see the paper, I could see how to do the problems, but how do you do a geometry problem? Well, you write an essay on it, basically. You say, it's a little bit of words, it's all words. You have to say this goes here, and then why is this true? Because so-and-so implies so-and-so. And it's words like that. And I was slow. I was slow at writing. And I only got halfway through. I didn't finish the paper. Whereas with the algebra, you do this, you rattle through it.
Okay.
And you don't have to compose sentences. You just write down the algebraic equations.
Obviously, a theme of your career has been incredible success and whatnot. But another theme of your career and your life, from what I'm hearing, is things you didn't quite finish because you were a bit slow at them.
Absolutely. Well, that's even though I'd speeded up enough to get through my school exams.
Yeah.
I was still slow.
Yeah.
And I showed up when I was doing my geometry.
Are you still slow?
Yeah. I think so.
Yeah. Or methodical. Is that a nicer way to say it?
I'm not sure it's quite right. I think it's partly, now this is probably more true, that my thought processes are a little bit different from other people's on the whole. So if I hear, I have to translate it into my way of thinking. I don't know if that's it at all. There is something of that in it.
Yeah.
But I like to work things out for myself. I gain most from lectures and things like that when I see the general idea. And then I go away and figure it out my own way. If it's a lecture course which is just following equations, I get lost. That doesn't help.
Right.
But if I can see the general idea and I can go back and go through it myself, then I can do it.
You've got this own personal language you then convert into inside your brain, do you?
I think there's a lot of that in it, yes. And a lot of it is visual.
Right.
Many lectures in mathematics are not very visual. And I learned this too. When I tried to do diagrams and things, often people have trouble. That's it. And I remember early on when people maybe suggested my giving a popular talk in the early days of this. And they said, oh, well, lots of pictures. People like pictures to understand. And I thought, that's interesting. Because when I talk to undergraduate mathematicians, they don't like the pictures. They like the equations and they want to make sure they can do it that way. I don't know, some do and some don't.
Professor, I spoke to a physicist friend of mine the other day who went to a lecture of yours in the last year or two. And I said, what was a Roger Penrose lecture like? And he said, it was pretty good. But the thing I remember most is he did the best drawings of any lecturer I've ever seen. He said your drawings were incredible.
Well, I did. I guess that's also the artistic strand in my family, because I hadn't said this before. My father was a very good artist, actually. Right. But he was one of 4 brothers, all of whom were. In fact, his younger brother, Roland, became a big figure certainly in Britain, in the Surrealist movement. He more or less founded the Institute for Contemporary Arts. He was a good friend of Picasso and various of the people in the Surrealist movement.
Do you take pride in your drawings in lectures and books and things, or to you is it just a means to an end, and if people say you're good at it, well, that's nice?
I do take pride in it. In fact, I like to draw all the diagrams in my books, which I do. Early on, I got somewhat sort of talked out, browbeaten out of it to some extent. Yeah. And I would sketch them, and they were then redrawn professionally. Later on, I got to learn that correcting the professional drawings was more trouble than drawing it myself. They wouldn't get it quite right. And I said, look, this line goes in front of that, not behind it. And drawing them as though they neither of them went in front or behind was...
There are whole websites dedicated to Roger Penrose drawings now, so you're obviously doing something right.
Well, I don't know.
When you look at the list of prizes and honours and things you've won over the years, it's quite a long list. So can I ask, is there anything that you have won or anything that's been bestowed on you that meant more to you than the others, that was particularly, you're particularly proud of, if I can put it that way?
I think there are a few. Well, the thing that shook me first was I suppose, the one I got. The trouble is I'm going to forget all the names of these prizes. So not even try, because my memory for names is...
Professor, I think in the industry that's called a humblebrag now, when you say, I can't even remember the names of my prizes.
Oh, yeah, that's not so good. But I guess the thing was about the knighthood, I don't think that was just strange. I didn't quite know why I was giving that.
Who bestowed your knighthood? Which member of the royal family did the sword?
It was indeed the Queen who did, yes.
Oh, you got the Queen.
Yes. The thing that I remember worrying about was you had to kneel on one knee and not on the other. And I get one of the confusions I have in life is not remembering which is my left and which is my right. So I might have done the wrong way around. I was greatly relieved that they had a special chair that you can only do it one way.
Okay. And did the Queen say anything to you? Did she ask you anything about space-time curvature or black holes? Or
I'm not allowed to say anything. I didn't even remember that at the time.
Yeah.
I had more of a conversation with the Queen with the thing which did mean more to me, I think, which was the Order of Merit.
Right.
Because it's limited to 24, 25 people, whatever it is.
That's a very exclusive club that you're part of.
That was a totally unexpected thing.
What did you talk to the Queen about then?
That I'm not allowed to say.
Oh.
Yeah, it was an interesting... I didn't know I was not allowed to say, because I learned later from people that you're not supposed to say what the Queen says to you.
You can just tell me. One thing I would like to ask you about, because it's a personal fascination of mine, was what was it like becoming a Fellow of the Royal Society and signing that famous charter book that Isaac Newton and Hawking and everyone else has signed?
That was nice. But he hadn't signed it by then.
Oh, yeah, you got in before him. You mentioned to me your father was at your induction into the Royal Society, which meant something to you.
He was very proud of having father and son until he tried to track down how many other... There were quite a lot of them, I should say, fathers and sons who were FRSs at the same time.
Oh, your father was an FRS, was he?
Yeah, he was an FRS at that time, yes, that's true.
I hope at that point your father leaned over and said to you, okay, you made the right decision going for mathematics.
Oh, no, he was proud of it. He definitely was proud of me.
Many of Professor Penrose's discoveries are linked with Stephen Hawking. In fact, in the recent movie of Hawking's life, The Theory of Everything, he attends a lecture by Roger Penrose. This is shown as a pivotal point in Hawking's career. Penrose is later shown as an examiner for Hawking's PhD thesis. I mean, you obviously worked with Stephen Hawking a lot. Was he a friend of yours?
I got to know him, unlike what the film suggests. According to the film, there was a lecture given by me at, I believe, King's College London, and it was on black holes and things. And there was Stephen in the audience, and there were sparks coming out of his head by his being inspired.
Right.
I did give a lecture on black holes, my theorem on black holes, in King's College London. Stephen Hawking was not present.
Right.
However, J.L. Singh was present. I was very proud of that, because he was a geometer who was a relativist who had written a book, a geometrically oriented book, which I got a lot from. I liked his book very much. So I liked his way of doing relativity. Anyway, I gave this talk on black holes and why they had singularities in the general case. And it wasn't just the symmetry and the fact that it was just dust and so on, that whatever matter you put in, and it could be very asymmetrical, and it always produced singularities. And Dennis Sharma, who I had worked with a lot before and who had become Stephen Hawking's supervisor, Dennis Sharma heard of this talk and suggested I give a repeat. Right. The talk was given in 1964,
right,
in December, I think, and I gave a repeat in Cambridge in early 1965. And Stephen Hawking was present at that talk.
Okay.
But the main thing was not so much his being present at my talk, but that he afterwards, together with George Ellis, and I believe Brandon Carton might have been there. I'm not sure about Brandon. But this was a more private little session where I explained the details of the techniques that I was using.
Okay.
And this was where I really got to know Stephen.
Oh, these little details don't matter for Hollywood movies, Professor. But what was your relationship like with Stephen Hawking? What was he like? I mean, you're in a select club that gets to have this kind of not only a relationship with him, but an intellectual relationship with him.
The film is partly correct in that I was one of the examiners for his PhD thesis.
Right.
Dennis Sharma, who was the supervisor, in those days the supervisor was supposed to be one of the examiners.
Yeah.
So Dennis was one, I was one, and according to the film, Kip Thorne was there too. I don't know why they put Kip Thorne there, because he wasn't there.
Right.
We only had two, so I don't know why they wanted him.
Yeah.
But it was an interesting occasion because I'd read the thesis, which had 4 parts. And I remember I said, I think in my write-up of the account, that any 2 of them were good enough for a PhD.
All right.
I made a note of various mistakes that there were in the main thing, which was his main thing, which is the final part, which was the singularity theorem part. And in the interview, Stephen had found them all. So
he'd already picked them up.
He'd already picked them up. And I think it was he'd made errors previously. It was interesting because you can have errors of the first kind and errors of the second kind. Errors of the first kind, which is when you correct them, the theorem still works. Errors of the second kind, as they wreck the theorem.
Okay.
These were all errors of the first kind, so that although they weren't technically quite correct, where you could correct them by planting the argument by a slightly improved argument.
What was he actually like to work with, though? Was he funny? Was he just blindingly smart? Was he quite dry?
He certainly could be funny. He certainly was funny, yes.
Yeah.
I'd have to think back. You see, the disease took a long time before it was hard for him to talk.
Yeah.
And then it got very difficult to talk, and then he got his machine.
Yeah.
That was only after he had his tracheotomy, and then he couldn't talk at all.
Yeah.
When he was in Switzerland, he got pneumonia very badly, and he almost died of it, and they had to make a hole in his neck so he could breathe through it, and then he couldn't talk at all.
Yeah.
And he got his machine, and after that he spoke with his machine.
Can you tell me how you have an idea, where you do it? Do you get it swimming in a lake, standing in the shower, out on a run, sitting at your desk at work? Where do ideas come from? In dreams, maybe?
Well, I can tell you 2 things which I don't get them in. You've just mentioned 2 of them. One is in my office. When I say my office, I don't mean my messy thing at home where I sit and do other things in, but I mean my office at my university.
Right.
I don't think I've ever had a good idea in my office, wherever it's been.
Right.
In a dream, I've definitely never had a good idea in a dream. I've had ideas which I said, gosh, that's a brilliant idea in my dream.
Yeah. I've
had them where even I've woken up and I thought, that's a great idea. Wow, this is the first time I've had a brilliant idea in a dream. And I remember one day, it took me full 10 minutes when I realized how stupid it was.
So you wake up thinking you've solved the Riemann hypothesis, and then you watch it fall apart over the space of 10 minutes.
I've never done that one yet. No, I have thought in a dream, but they've all been complete rubbish. Not just wrong, utter rubbish.
Where do you have your ideas? Can you think of any times or places where they've happened, like walking in the mountains, crossing a bridge?
Yes, I'm sure I've had one crossing a bridge, but I can't remember when and where and what. I've had it, I think, in the mountains, yes, or walking. Yes, definitely.
Yeah.
Shaving, I used to think was a good time to. I don't know. You won't know about this, but I suppose you trim your beard sometimes.
Yeah, I have shaved.
There was a period when I tried to grow a beard once too. It was a disaster. But no, shaving I used to think was a good time, but I have not had a good idea shaving for a long time.
But you used to have good ideas shaving.
I do.
Why?
I guess it was just a relaxing moment. I don't know.
Yeah.
It's usually when you're thinking of something else and it clicks with something. You see one idea on another topic and you think, oh, and you can realize that there is something similar in another line of thinking. That is a big thing.
Right.
And it can be not quite the same. You see, that way of thinking about something reminds you of a way of thinking that you've thought about something before, and it was in a different problem maybe. And that can be important, yes.
Can you ever have ideas when you're with other people, like interacting in a room and standing at a blackboard with a colleague, or are you normally on your own?
I can't remember whether I've had to go there in a party or something. I remember thinking that maybe a bit of alcohol would help me in a party. And I used to think when I got home, and I'd actually had too much to drink, and maybe this would give me a good idea. And then I started thinking about some problem. And this happened more than once, twice, at least twice, that I'd found a mistake in what I'd done when I was sober. So it wasn't that I had a good idea from being, I was actually able to go through it more carefully and see where I made a mistake.
So you're doing your own peer review.
My own peer review. But I think there was this occasion, which I know people often quote, where I was worrying about the black hole problem. And I had developed certain techniques because this was a time when the quasars had been discovered. And these were very luminous objects, brighter than an entire galaxy, enormously far away because of the redshift. And people used to argue, is it a real redshift? Is it some funny physics? Is it gravitational redshift? It really part of the universe expansion? Is it an anomalous motion or all sorts of things? And they sort of concluded it really is a universe expanding. And so it really is, they really are that bright. And that bright and that small. Why that small? How small? Well, because the brightness varied to a degree within a week or so. Within a week, well, that means they're smaller than the solar system because the time it would take light to get across from here to Saturn, I can't remember, but a long time. And the time, it would mean that the thing was smaller than the solar system. And if it's smaller than the solar system, then it would mean you run into problems with general relativity.
Okay.
And so people started to worry about that. And they brought up this old paper by this Wheeler, who I worked with at one stage. And he was rather keen to get people to look at this old paper by Oppenheimer and Snyder, where they had studied black hole, what we now call collapse to a black hole, but this was, the material was just dust, which has no pressure. But it was just called dust. It was zero pressure material, so nothing to stop it collapsing. Spherically symmetrical, and so it just focused itself into the middle. And so the density would become infinite, the curvature would become infinite. You get a singularity in the middle. Is that real? Or is that just an artifact of the lack of pressure and of the fact that it was focused into the middle? Well, there were a couple of Russians who seemed to have proved, this was Lifshitz and Khalatnikov, who seemed to have proved that in the general case, you wouldn't get singularities, things swish around and swirl out or something like that. And so that was a sort of common belief. And so, I don't know, it doesn't explain the quasars, but maybe something did something like that, or I don't know. And so the question is, did you get these singular states where the curvatures become infinite, the densities become infinite, the equations simply give up? I started worrying about this problem. I looked vaguely at the Lifshitz paper and come to my conclusion that although I didn't know there was a mistake in the paper, which there was, I thought the techniques they were using, well, clever, they weren't the kinds of things that you could really get a proper proof that there was no singularity. So I thought the question was a bit open. And I had developed techniques from other things I was thinking about, looking at general relativity from global, not solving equations. I wasn't good at solving equations. I could do it occasionally, but that wasn't my skill. I could think about these things geometrically, look how light rays behaved and how they focus and how boundaries of future sets and things, what they looked like, and the kinds of singularities they had and the properties that they had. So I was getting quite familiar with that kind of thing, but I had no characterization of what a collapse to be on point of no return. You see, when the collapse goes to a certain point, it's nothing you can do about it. It's had it. So what is that point? And how do you characterize in a way which doesn't depend on symmetry or solutions of equations or like that? So I hadn't got my mind around that exactly. And there was this occasion when I had you asked me about conversations with people. Ivor Robinson, who was a colleague of mine for quite some while, I'd known him for a long time, and he had a way with words. He was English, but he was working in Dallas, Texas, where he spent most of his later life. Well, they all loved him because of his way with words. And he was talking to me, and I don't know what he was talking to me about. And we were walking along quite near to Birkbeck College, where I was worked at that time. And there came a sort of crossroad, side road, and we crossed the road. And as we crossed the road, we was looking for traffic, and the conversation stopped. We got to the other side of the road, And he went on talking to me, talking. And then he went off. And that was the end of my conversation with him. But then I had this strange feeling of elation. I thought, something was good. It wasn't just the conversation. I tried to think of the conversation. Was that? No, it wasn't just that. Was it something I had for breakfast? I went through my life, all the things that happened to me the day, until I got up to crossing the road. And then it came back to me that I'd had this thought of how to characterize a state, a point of no return, which is what I call the trapped surface. It was not a local property, but it was a global property of a surface, a two-dimensional surface. When it had this property, this was too late. It had had it, and this was the end of it. So I went back to my office, and I sort of sketched out a proof using the methods I'd thought of singularity result. It needed improving. I had a version of it in the paper, which I lectured about and which was published in 1965 in Phys Rev Letters.
So that could become a new joke. Why did the mathematician cross the road? To better understand singularities.
That's right. Yes, well, that's right. So I don't know what would have happened if I hadn't had this impetus to try and, I guess I tried to think of what thing was in my, I've tried to do this, after that time it was successful. Often I have had thoughts in my mind. I thought, what is that strange feeling I have? Where does that come from? And I just never been able to trace it down.
Penrose tiling is one of my favourite discoveries. This is a system of so-called aperiodic tiling with, amazingly, just two shapes that'll perfectly tile an infinite plane. No gaps, no overlaps, but also in a way that never repeats. Now, I've left out a few details, but if you're listening to the YouTube version of this podcast, I'll show it on the screen right now. There are also plenty of other places where you can read about it and see examples. I'll include some links. I won't ask you too much about Penrose tiling because it's quite detailed and it's quite a visual thing, and this is not going to be a visual thing that we're making. But, well, one of our listeners asked the question, does Roger Penrose have Penrose tiling in his bathroom? Do you have Penrose tiling anywhere in your house?
No, except in, I suppose, in some pages in books and papers in my bedroom, yes. No, Penrose. And another person asked me to ask you, what does he feel about the whole toilet paper debacle, which was when a big American company used Penrose tiling as a pattern on their toilet paper, and there was legal action and all sorts of stuff kicked off. How do you recall that incident? Was that an amusing thing? Were you upset by it? No, it didn't mean that much to me. You see, I think we'd moved into our new house, and I think we'd just gone in, and there was a loo roll in there.
What, left by the previous owners?
By the previous people. I think some people who'd rented the house and left the loo roll.
Yeah.
And I don't think, I looked at it and I couldn't see it very well. I don't know if my eyesight was bad at that. No, it wasn't something else. My eyesight was probably not very good. I just saw it with some pattern on it. I didn't even look very carefully. Yeah. But my wife, Vanessa, had looked at it and she noticed it seemed to be what people call a Penrose tiling. So she said, have you looked at that pattern? So I looked carefully at it and I saw there was a big stretch of it and it wasn't completely right. There was places where it had cheated. But apart from that, yes, gosh. There was a person and he was making puzzles and things using, with my permission, making puzzles with my tilings and things like that. Some quite nice ones. But it was not very commercially successful because at that time the techniques for making these shapes was a bit expensive. But anyway, he took away from making these things and decided to sue the company which made the toilet paper.
Right.
And I thought this was a pretty dead loss, but he decided to do it.
You were quite arm's length from it all.
Yes, pretty well. But what he did want me to do was to find all the places where people had published articles with these tilings in them and who had written the articles. I think that was what it was.
Yeah.
There was an article by Paul Steinhardt, I think, on quasicrystals or something, what it was now. I just trying to remember. And he had used a tiling pattern, all with permission and everything like that. It was fine. But what my colleague who was making the puzzles wanted me to do was to get all these people to say that this pattern was done with my permission. You see, that it was my design, and it was done with my permission. And so
Right.
they all did, perfectly obligingly did, and that was fine.
Yeah.
And so he decided to have a court case, and he had these people up.
Did he win?
It was agreed out of court. There was an out of court settlement.
Right.
There was an amount of money which was incoming, which, as far as I know, more or less covered the costs.
Were you upset about it? Were you upset that a toilet paper company had put Penrose tiling on their loo roll, or did you not care?
Honestly, I didn't care too much.
Yeah.
I think I was a little bit upset. I can't really remember.
Yeah.
It wasn't a big thing for me. Because other people use tilings on buildings.
Yes. I've seen several buildings with Penrose tiling on them.
Some of them have had my permission and some haven't.
Yeah.
Have asked me and some haven't.
Do you feel that you own the tiling? I mean, did you find the tiling or did you invent the tiling?
Discovered is the word.
Discovered.
There's a curious story about that. Gosh, there are all sorts of curious stories. Because I was just playing around with designs, and I had played around with patterns which cover the plane, and I'd seen a lot of Escher patterns, and I was very intrigued by how you could make birds and fish and things, do all sorts of clever things. And I liked the idea of patterns which maybe didn't repeat themselves. And I had come across a letter with a logo from somebody who'd written me a letter, and I'd been very long, never answered it for a long time. And the logo had a pentagon, regular pentagon, 5-sided shape, with 5 ones just in it, one in the middle. So there were 6 all around, and little triangular gaps in the middle. So I looked at that, trying as an escape from writing my letter. I wondered what would happen if you iterated this. You put this whole pattern inside one of the pentagons, you did it again and again and again, stretched it out, and made a big pattern. Now you've got lots of gaps here. And I thought of a way of filling the gaps, a sort of systematic way. And it made this pattern, which I thought was rather attractive.
Yeah.
All sorts of almost repeatings and lines and things. I thought it looked nice.
Inspired by a letterhead.
Inspired by a letterhead.
Yeah.
And by a logo. It was a logo, yes.
Right.
And so I sent this to a friend of mine who was in hospital, a woman I knew quite well, and she had an interest in mathematics. She was having an operation, and I thought this would cheer her up. And so I think it did. But somewhat later, I looked at this pattern, and I thought, I wonder whether you can make a jigsaw puzzle out of this, which would force that arrangement. Now, this is a sort of idea. I sometimes have ideas which I give about 50% being true, 50% not. It's not that, yes, I have the confidence that Poincaré seemed to have when he got on the bus, the famous story. Okay, maybe it's true, maybe it's not. Give it a good 50% chance. And this was one of those.
What was the thing that you thought 50% might be true?
That you might force this arrangement by putting little knobs and notches to make it into a jigsaw puzzle.
Right.
With a finite number of pieces.
Yep.
So finally I came round to 6 pieces. Each of the pentagons had to be 3 different versions of them, depending on how many pentagons were around them. And then there was a rhombus, which had to be done in one way, and a star, 5-pointed star, and a heart, sort of 3-pointed half star. And each of those, you had to put little things, knobs and little holes in them, slot them together, jigsaw puzzle-wise, and you couldn't do it only in a non-repeating way. I was quite proud of that. I think this was when I just had my job at Oxford. I can't remember which the ordering was. Must have been just about then. That's right. When I was at a gathering of some sort in Oxford, and I met Simon Cochin, who's a mathematician, who was a good friend of John Conway's in Princeton. And Simon Cochin had been talking to me about a non-periodic design, that is a jigsaw puzzle, which originally had to have, several thousand pieces, several thousand different shapes, and they would only tile non-periodically. And that Raphael Robinson had got this down to 6. And he told me that Raphael Robinson was a mathematician who really liked to get it right down to the smallest number. Some other people had got it down to about 100 or something. Robinson had managed it down to about 70. He got it down to 6. And I thought, I can do it with 5. Because I knew, not with, his were all little square shapes with little knobs, and not with square shapes, but with these funny shapes in mine, I could get it down to 5, because I knew there was a funny little puzzle knob and notch that you could only fit together with 2 pieces.
Yeah.
And you just glue those together. You'd have to do 2 of them to do it together. And then you could do it with 5. And so I said I could do it with 5. I then went home, fiddled around a bit, and I got it down to 4. And I thought, well, that's pretty good. I can do it with 4. I was quite proud of that. And I thought, well, maybe, is that the best I can do? And I just fiddled around, and I got it down to 2. And my main reaction to that was disappointment, which you may think is a strange reaction. I'm not quite sure why I was disappointed. I just thought, this is just too damn easy. This is so simple. I think it was the kites and darts and then the rhombuses. That's so easy. Why hadn't it been thought of before?
Did it feel like a big deal? Did you think people are going to love this? Or did you think it was trivial?
It's funny, I thought it was too easy.
Yeah.
That was my initial reaction.
You thought someone must have already done it?
Yeah, I don't know why I thought it was. I'm not sure whether I thought somebody must have done it. That was part of it. Maybe a nuisance. You'd have to track down and see whether somebody who would know, that sort of thing.
Yeah.
I was at a mathematical colloquium. This was in Exeter or something. I can't remember if it was that one or another one. And I knew John Conway, and he was there too. And he asked me if he'd done anything interesting recently. I thought, yeah, I have done a little thing. Yeah. So I showed him, and he picked up on that. And then he went to have a session with Martin Gardner. And Martin Gardner's article was based on the session that he'd had with John Conway. So they found out various properties that these infinite patterns would have.
How do you feel when you see the Penrose tiling used in some way on a building or just in a beautiful way? Like, do you look at it and feel a warmth or an attachment or an ownership or an affection? Or what does it do to you?
I have various reactions. It depends how if they've done it well, I feel pleased with it, yes. If they've done it well and they've previously asked my permission and I said yes, then I feel pleased with it. If they've done it well and they didn't mention it to me at all and they just did it, I might feel quite pleased with it, but I wish they'd asked me first.
Yeah.
Some of them do. Some of them I hear about it, and then some of them I do it in a way which I don't like very much. There are some of those. Some of them I feel they've wrecked it. Yes, I have had that view sometimes.
You're not going to name names of someone who's wrecked it.
I guess the one which I guess I'm most proud of, was because I had a lot of hard work involved in that, was the Trans-Bay Center. What's it called now? It's got another name to it, in San Francisco. No, the architect there, and he's a very nice fellow. And he got hold of me, and he said, they sent me, it was a quite curious reaction I'd had, because I think they'd emailed me, and I looked at the email, and I had this sort of reaction I often have when people want to use my patterns. Oh, well, this is somebody wants to make a cushion. You know, a lot of people ask, listen, my aunt wants to make a cushion. She'd like to use your pattern on a cushion. And she said, okay. And so I'd write back and say, sure, it's fine, but just make sure she gets it right.
Right.
The only thing I fussed about is that she gets it right. So I've had the same reaction to this thing. I said, okay, make sure you get it right. And then I looked at it, and they'd had I can't remember how much I could see of it, but they'd done it by making big panels, and they'd repeated the pattern on the panels, and that I didn't like very much.
Oh, that kind of defeats the whole purpose of a Penrose tiling.
Well, I did feel that, rather.
So they did a good job, but you kind of wish they didn't do it with the panels. It's one of the sort of cliches of science, and particularly mathematics, that the best work is done by mathematicians when they're young, the Fields medals given to people who are under 40, and it's considered like a young person's game. How do you feel about that? And how do you feel your brain works now compared to when you were 20 and 30? Do you feel like you're still firing on all cylinders? Do you notice differences in the way you think now?
I think there's some differences. I noticed the main difference is when I was a graduate student. I think at the beginning I was all over the place. That is, I was thinking about things, sort of unconnected things, not necessarily on the problem I was working on. And on the problem I was working on, I was drifting off in all sorts of other directions.
Yeah.
And I was trying to develop notation from tensors. A lot of that was doing that. Right. And developing these notations in sort of abstract ways which weren't at all connect with the problem I was working on. So it was sort of all over the place. Later on, I think, as I got more focus, and it got more into the physics. So I think it was when I was an undergraduate, I was sort of interested in general relativity a lot. And Dennis Sharma was trying to focus me much more into cosmology and general relativity and the steady state model, which was a thing in those days. And he got me interested in that.
If you went forward in time 1,000 years, what was the first thing you'd ask or look up in a physics textbook or ask a physics professor?
It's a difficult problem for me, you see, because I could say, with one hat on, I could say, look, we're so far away from it, we're close. I probably wouldn't understand a word it said.
Right.
I would love to see that book. It would probably take me a whole 10 years course to understand what the mathematics is, how on earth this explains anything.
Do you think over 88 years, you've done a good job of work-life balance? Or do you have to be a workaholic and always be working to put these runs on the board?
I could answer a question to say, I've done 88 years of good work, and I'll go and watch the telly and maybe paint or draw pictures or do other things which might even entertain me more than what I'm doing. I don't do that, not because I think people aren't paying me enough attention and therefore I've got to publicize myself and point out certain things that people haven't noticed. And
do you watch TV shows? Do you watch Netflix? Do you watch the cricket? Do you go to the movies?
I don't have a television, so I don't watch. I can watch some things on Netflix. I would occasionally if there's something very special. Yes, I would. I have watched occasional ones.
What's the last thing you watched on Netflix?
I watched a movie which I really enjoyed. That was the one on Marie Curie. No, I really like that movie.
What else do you sometimes tickle your brain thinking you would like to have done, maybe, if it hadn't been the math and the physics?
I think probably painting or something I did on it.
Yeah.
Even possibly music. Now, there's a funny one. I wouldn't have probably been any good at it. But I had a colleague when I was with Christopher Scraichie, and the only group I ever had anything to do with computers, seriously. And Colin Merton was a work colleague of mine. He had a zither, which he had tuned 19 to the octave. So I call that 19 to the dozen. And that is the next good equal temperament scale. 12 is a very good number. So you can get the Pythagorean scale to very good approximation using 12 notes. The next good scale is 19. And you could compose music 19 to the scale. So he then gave me eventually this zither of his, which he tuned 19 to the dozen, which was a huge mistake because it absolutely went out of tune before you knew where you were. It didn't like being tuned 19 to the dozen.
Right.
How you retuned it 19 to the dozen, I had no idea.
Do you play any conventional musical instruments?
Well, I used to play the viola, which also was a mistake because I should have learned the piano. No, I enjoyed playing the piano and sort of improvising. That was anything I used to do with fun. But I never was really very good at it. So I never could read music now.
It's been a real spanner in the works, COVID-19. Has it been a real spanner in your life, the pandemic?
It's a spanner, but I'm not sure whether it's a spanner which I've been opening safes with or not. I mean, it has changed, definitely. I had tours all over the place planned to go and pick up actually Paris prizes and things too. Cambridge honorary degree and 3 prizes. Yes.
Yeah.
All of them. I've never done many of them.
But you've seen a silver lining to it, have you? Has it helped you focus on your work?
It's meant I changed what I wanted to do. I have this. Well, there is this plan to write the Escher book on, and that's taken a breather for a while. No, but I sort of something else. I thought there are a lot of sort of vague, unthought, not completely thought ideas out about the collapse of the wave function. So I think it's gravity. So it's how gravity interrelates with quantum mechanics. It's not quantum gravity. It's not you should quantize gravity like what everybody else said. You should gravitize quantum mechanics. It's the other way around. And there are a number of other people who want to do this. Limited, but quite a few.
Do you work long days? Do you get up at the crack of dawn, or do you sleep in, and do you work till midnight, or do you
work long days, but they start quite late. They tend to end at about 2 a.m.
Oh, okay. What time do you get up then? About 10 or something?
I get up at about 9.
Okay.
You see, by the time I've got to sleep, it tends to be about 2 or often later, unfortunately. And then I wake myself up at about 8 and then get myself up.
Yeah.
I'm a bit slow at doing all these things. So I don't get started until about 11.
That's okay. If you're working till 2 a.m, I think 11's okay to start.
But I'm not very efficient. And then I try to get my things working. And then the emails that I've got to reply to and don't get them working.
Well, thank you for replying to my email. And thank you for so much of your time today. I will let you get back to your work. I see it's your birthday coming up soon, so maybe I'll try and get this podcast ready for your birthday.
Just in a couple of weeks. I forget what the date is. But yes.
Do you enjoy birthdays?
I endure them.
Well, as it happens, this podcast is being released on the day of Professor Penrose's birthday, so I'll end by wishing him a good one, and thank you for all his time. I'm Brady Harron, and you've been listening to the Numberphile podcast. Check our feed for more episodes and the podcast description for helpful links to all sorts of other material. The podcast is made possible by support from the Mathematical Sciences Research Institute in Berkeley, California, and you can also support us on Patreon by going to patreon.com/numberphile.